for example, a concert or a sports game. Wireline networks are not that dynamic in terms of traffic modeling. So the way DPI can and should be deployed in wireless networks ought to be different. It needs to be different to be optimized. So just to kind of look, again, and kind of compare and contrast wireline and wireless, both DPI markets are projected to grow rapidly. These are figures from Light Reading. And in fact, we believe that the figures are actually quite conservative. Given the rapid projected growth of video in particular and what that effect that has on the overall traffic flow, we believe that mobile DPI is actually going to go even faster than what is projected here. So let's talk about today's solutions. I mentioned previously that basically wireless DPI solutions are being deployed roughly similar to wireline, and this is kind of a natural migration from one environment to the next. And there are typically now standalone boxes from vendors that have provided DPI solutions in wireline. They're just basically deploying into the wireless networks, as you can see, between SGSN and GGSN. But this really does not afford the operator the ability to treat end users differently based on either their willingness to pay, their applications that they're using, or the actual congestions in the network. It's kind of more of a one-size-fits-all type approach, which is not optimized for the specific wireless reality. But if we look at an alternative, what we call adaptive traffic shaping, which moves the DPI functionality one step closer to the edge, this enables a couple things. One, wireless operators can incorporate what's called internet traffic offload. This is basically shunting off internet traffic before it goes through the mobile core, so thereby freeing up mobile core bandwidth for other applications, whether that's its own or a partner's premium video content or other voice content, for example. It also enables the traffic shaping ability to be more optimized for the specific sites that are close to that edge point. So, for example, the airport sites or the sports sites or near the major freeways and rush hour type times of day, incorporating the dynamic loading of those sites. And operators have a much finer ability, more granular level ability to employ the vast capabilities of DPI at the subscriber level. So it's time of day, location, dynamic loading, application. They can factor in all those things. So if I bring it back to the system level and say, okay, that's great, we understand DPI needs to be deployed strategically in wireless networks. It's not just copying how it's done in the wireline networks. And as Bill described, there are certain applications or elements in the system that need to be considered. So what? What do I need to do? What are steps that I can take either as an equipment provider or as an operator, things that I need to focus on when I'm selecting equipment in order to address the video challenge? What are the different elements of the system itself that I need to be focusing on? And so what this chart is showing is all the various elements, and it really understands the concept that it needs to be a holistic view. There's not one element which will solve the whole thing. It's like a chain, and the weakest link. It's not like you can put in one really strong link and then therefore the overall end-to-end service delivery is optimized. You need to look at each element, at the high availability middleware itself, how the applications are optimized, the policies within the operator of how DPI is employed or applied to the various traffic streams, the internet offloading, shunting traffic off in order to create more bandwidth, and then that market tiered pricing for the various streams. So to put a little bit more specificity into this, I'm going to hand it back to Bill, who's going to walk us through an actual real-world scenario with real-world customer and the specific considerations there. So, Bill, back to you.
All right, Brian, great. Appreciate that. I'll go quickly through this so that we've got some time for questions. I see a lot of really good ones have come across over the last 40 minutes or so. This is one of the customers that we've worked with Continuous Computing on. It is a leader in the 4G space with multimedia controllers, and they had some of the classic problems that we've been talking about today, where they had new capabilities that they wanted to introduce into market. They had some very aggressive time-to-market requirements and wanted to build a very flexible and scalable architecture that had that high availability, but also some of the DPI capabilities that Brian alluded to. You know, what they stepped in with is not all of, but a good part of what that previous slide was that Brian showed, some of the key capabilities that are part of this COTS ecosystem. The continuous ATCA hardware with packet processing, storage, and security, and that typically is pre-integrated with go-ahead Sapphire high availability middleware, so that integration work is taken off the plate of the provider and put back on the plate of the vendors that are servicing them. Really, the results of this were a product that they were very excited about, 5 nines availability, scalability, meeting their very aggressive demands, but most importantly, most importantly, they achieved a first-to-market advantage by leveraging the COTS capabilities, and they accelerated their time to market from 36 to 14 months. So a very aggressive timeline, and quite honestly, folks, these guys haven't looked back since. So before we launch into the Q&A, what I wanted to do was to push out one more poll question, just to get a sense of what portion of our audience is looking at delivering some sort of equipment to market that does have the sorts of high availability carrier grade capabilities on any number of fronts that we've talked about today. Now, I'm going to leave that poll question to sit for a couple of minutes, and in fact then turn it back over to Monica so she can start our Q&A session.
Okay, thanks so much, Bill. And thanks, everybody, for those great presentations. We've got a lot to talk about and a lot of questions, a lot of good questions coming in, like you said, Bill. Just to kick things off, I wanted to touch on, I guess, kind of a current event, and this is really a question directed at the two Brians. The FCC has signaled that it will be applying net neutrality rules to wireless. A lot of people are curious how will that, or what effect, if any, will that have on mobile video? And then along those same lines, should mobile video be given a higher or lower delivery priority when compared with other applications? And, well, maybe I'll first ask Brian Wood about your answer to that. I know you brought up DPI.
Sure. Thanks, Monica. So I have, I guess what I'll call a market-based approach. I don't believe that it should be mandated, that it should be one-size-fits-all as determined by a regulatory body. I think that individual operators and their subscriber bases should be determined. It should be market-based, competitive. This is, one of many elements among which operators will compete. Like I mentioned, wireless networks are a different animal than wireline. And so just taking one policy set and applying it to the other, in our opinion, is not the right approach. So, using technology solutions enables operators to give everybody, all subscribers, a quality of service, and it doesn't allow a minority of users, so for example the peer-to-peer users, in those applications tend to suck up nearly all of the available bandwidth, preventing a minority of users from disrupting the quality of service for everyone. So we believe that operators and their subscriber base should have the opportunity to figure out the right balance points for themselves.
Okay, thank you. Brian Partridge?
Yeah, the only thing I'll add, because this could take up the entire Q&A session, and we have, we produce reams of perspective on neutrality, but in thinking of on the wireless side, it really is, I think it was mentioned in the presentation, it's a much different animal than on the wired side in terms of bandwidth and spectrum constraints. And so to the degree that we're dealing